So let's do part 6. Because this takes us directly now. We've got all the ingredients that we need to define a circle. Not a circle, an equation or a function. Even a circle. But the circle will be the last thing. So let's clean our board. How should we clean it? How do you prefer it? I don't know. Let's clean our board. And I just like to state that as I'm cleaning the board, the axioms I'm not cleaning out. Because I want them to be fixed in your mind. That a number multiplied by a unit is that number. This is a rewrite. I'd like to rewrite this in another way. Because of the first axiom, right? Maybe you'll appreciate the logic now of mathematics. Right? I can write A as A times 1. There, I've written it, including this one. Okay? Now I interpret the statement. Everything is divided. I say 1, this one. Maybe we should use color, right? Let's bring in the green. 1, 1. Now I'm going to take this one, yeah, and divide it by this A, The multiplication stands, and I'm going to take this A and divide it by 1. This A divided by 1. It's the same thing. Now look at this expression. A number divided by 1 is that number. But I like to keep them 1, meaning 2 is the same as 2 divided by 1. Any number is a number divided by 1. Any number divided by 1 is that number. Do you know what this number is called? Look at this number. It's got a numerator and a denominator. I swap them around and come here. Do you know what this number is called? Relative to this number. It's called the reciprocal. It's going to help you to understand how to solve equations. This guy, exactly this guy, and this guy are going to help you. Let's do a couple of exercises. 2a plus 3b is equals to c. And I ask you to solve for b, meaning I only want to see b here. It can be here, but it must be standing alone. You say, I don't know how to solve for b, but I do know that I don't like this guy here. He must be on the other side, because I want b here. So you say, oh, these guys are adding. They're adding. Right? So I need to remove this guy, which is adding. And I bring his inverse, which is negative 2a, the inverse of this guy. That's the inverse law. And when I add a number to its inverse, this guy is going to be 0. But when I do this side, I must do this side. So there I am. I'm left with 3b now. Is equals to c over minus 2a. It's just a crash course to make you appreciate these axioms now. Now I want to remove this one, the 3. But any number divided by 1 is 3. Now because it's multiplying, I need to multiply this thing by the reciprocal of this. Because a number multiplied by its reciprocal will give me 1. So the reciprocal of this number, 3 over 1, is 1 over 3. But you were doing it on the side. Now you need to do it on this side, 1 over 3. You multiply the whole expression. This is what you call 1 times b, which is c minus 2a multiplied by, or rather, if you wish. I hope you understand this. If you don't like it, 1 over 3. 1 over 3. What is 1 times b? Well, I have this, that a number multiplied by 1, and this obeys the commutative law, meaning 1 times a, 1 times b is b. There, you solve for b. There it is. B is this beast here, whatever this is. The number was adding, because on the addition, to remove it, I must add its inverse. If it was subtracting, I will add its inverse, because the inverse of 2a is plus 2a. Changes the sign. But that means I have to do this now. This will become 0. If it was dividing here, 1 over 3, well, the inverse is 3 over 1, which means everything will be 3 over 1. And these guys, when they multiply, they must give me 1 because of this. And I still remain with that b. Now is 3 times everything. How do I know? Because the 3 was here. Well, the commutative law. The bracket acts as a multiplier, literally, in an expression. It multiplies the whole thing, which means I can rewrite this as 3 times c, hence 3c, and 3 times this, or there's the plus, 3 times 2a. 3 times 2 is 6. This is 6a. We'll do more exercises about this.